Mark your own. Oh, gotta have my favorite student again. Good old Ann. I'll have to unfreeze the screen then, won't I? There we go. 29 kilometers, yes? Little hint, usually if I leave very little room to show work, it's because probably you can do it almost in your head. So if you're trying to do something long and complicated and I didn't leave you enough space, probably you're on the wrong track. Displacement, I see compass directions, Mr. Dueck. I need to draw compass rose. This person walks 11 north and 18 east, so it's going to look like this. 11, 18. There's the displacement. As a magnitude, it's going to be 11 squared plus 18 squared square root. I doubt this will work out evenly. 21.1, I'll take 21, 2 or 3 sig figs. I'll write 21.1. Units, half mark off if you didn't put kilometers. At, theta is always where the vector is originating from. Opposite, adjacent, I can go tan theta equals 18 over 11. Oh, that's a problem. Did you get 58.6 degrees? 59 degrees? I'll go 58.6 degrees. North of south, east of west, what of what? What I've drawn is east of north. Now, if you have that, you get 3 out of 3. I would also accept 31.4 degrees north of east. That would be if you drew the 18 first and then drew the 11. The way I would mark this, by the way, for 2 marks, I would give you 1 mark for the magnitude, a half mark for the theta, and a half mark for the what of what. Number 2. A motorboat heads due east at 16 meters per second across a river that flows due north. I see compass directions. You probably already have a compass rose higher up on your paper, but since I've scrolled down, I don't have it, so I'll put it there. The river flows north, so this river is going to run this way. The current is 8. And the boat motor, the engine, is 16. So if I add those two together, tip to tail, I'm going to get there's my resultant. Here is the velocity with respect to the ground, to the people on the shore. The magnitude is going to be 18 squared plus 16, sorry, 8 squared plus 16 squared square root. 17.9, is that correct? That looks right to me as well. This is meters per second. At, the vector is always where the vector, the theta is always where the vector is originating from. It's going to be opposite, adjacent. It's going to be shift tan of 8 over 16. I got 26.6 degrees. And that's going to be north of east. Or 63.4 degrees east of north if you drew the 8 first and then you drew the 16. Either of those is, here it wasn't quite as obvious. I guess I wrote the 16 first, so I drew that first, but whatever. For 2 marks, again, 1 mark for the magnitude, half mark for the theta, half mark for the what of what. Did I make a mistake? I see a bunch of puzzled faces. Am I wrong? Oh, no, I'm good. Okay. How long did it take the motorboat to reach the other side? I'm going to use time equal, well, first of all, I'm going to use this. d equals vit plus a half at squared, but I said to you we're not going to have any acceleration, which means I can modify this equation to d equals vt. So I'm going to use the idea that time equals distance over speed. Now the 155 runs that way. Which velocity am I going to use? The 16, not the 17.9, not the 8. By the way, you'll notice this is a tiny bit different from what we did in our river question in our notes. I think there I gave you the resultant and we figured out the engine velocity. Here we've come done the other one, right? It's going to be 155 divided by 16. 9.69, and that's going to be seconds. How far downstream? Okay, now they want me to find the distance, so I'm going to use d equals vt. Which v? Well, downstream is in the north-south direction, so I'm going to use Thomas the 8, the velocity that's in the north-south direction, and I'll use the time. I'm going to write 9.69, but I'm going to use my answer button, 8 times answer button. Do y'all get, oh, nice, 77.5 even? Yeah. 1 mark. Number 3, 2 marks. We're finding 2 things. It's probably going to be 1 mark for each component. We're pushing 67 degrees west of north. West of what? West of what? West of what? I'm going to go north first, like that. I'm going to go 67 degrees west of north. It's going to look something like that, where this angle is 67 degrees, and this is 140. Now, I can draw the components a couple of ways. In your notes, I always was able to draw the horizontal first and then the vertical, and I could, except this isn't 67 degrees. What angle is down here instead? Whatever 90 minus 67 is, 23, I think. And if you did that, we'll all get the same answer and you'll get full marks. I'm going to reluctantly draw my components, this time doing the vertical first, and then the horizontal. So here's Fy, here's Fx. Here's my theta. Opposite, hypotenuse, adjacent. I think cosine of 67 equals the the vertical over 140. I think sine of 67 is the horizontal. I think I had given you this silly y is sine only if you're doing a horizontal, if the angle is from the horizontal. So that stupid shortcut that I showed you doesn't always work. It's worth doing the trig. But now, times by 140, times by 140. So Fy is going to be, did you get 54.7? And Fx is going to be 129 if I go to 3 sig figs. How many things did we find? How many marks was this worth? 1 mark each. Sled is being pulled along the ground with the rope. I think if you pull a sled with the rope, typically the rope is up at a bit of an angle. Oh, 72 degrees, it says, with the ground or with the horizontal is often how we'll phrase that. Find the components. So I'm going to have Fx, Fy, and this is 117 newtons. Opposite, hypotenuse, adjacent. If I find Fy, it's going to be sine 72 equals Fy over 117. Cos 72 equals Fx over 117. So Fy ends up being 117 sine 72. 111. And fx ends up being 36.2. How many things did I find? How many marks was this worth? This one's going to be worth 1.5. This one's going to be worth 0.5. No, 1 mark each. Come on, people. Some of you are like, really? What? I should do that. I should just invent like a bizarre marking scheme. This is 1.63, and this is going to be worth 0.37. Okay? I see a compass rose. South of what? South of what? South of what? So I'm going to go east first. And then I'm going to go south of east. How many degrees? 65 degrees. And it's 25.6 kilometers. Whenever I can, if I can, I prefer to do the horizontal first and then the vertical. And especially because that's the angle that they gave me. So this is going to be, it's not a force. This time it's a displacement. So I'll use the letter D for displacement. Hypotenuse, opposite, adjacent. I think cosine of 65 ends up being the horizontal divided by 25.6. I think sine of 65 ends up being the vertical divided by 25.6. .6 cos 65. For the horizontal, did you get 10.8? Units, kilometers. Did I put units here? I hope I did, yeah. If you don't put units, I do take a half mark off. And it's going to be sine 23.2. Turn the page. If Mr. Dueck ever says, oh, sorry, how many things was I being asked to find, Nina? How many marks is it worth? 1 mark each? Is that what you're asking? Or anytime Mr. Dueck says tough question, be much more meticulous. Raise your paranoid game. I'm not going to take too many shortcuts here. Now, a number of you were wondering, Mr. Dueck, why is this worth 7 marks? I learned teaching physics when there was a provincial exam, and on the provincial exam there was always 9 written questions, and you know what they were each worth? 7. It's a marking scheme I got used to because it allowed me to give up part marks like candy. In particular, it allowed me, if you made only 1 dumb mistake but you did everything else right, to give you like 6 out of 7, let's say, to give you almost perfect. And so I will, on your tests, almost always have your written questions be worth 7. It's just, and I'll show you how all the part marks are given out at the end of this. The way I mark these, if you get the correct answer, Dylan, you get 7 out of 7. If you don't, I go hunting for certain steps that get you. That gets you 1 mark. That gets you 1 mark. That gets you 2 marks. That gets you 1. And I'll show you how that works. I would draw a compass rose first. And this is the airplane question. I'm going to probably go like this. There's 2 ways to do this. One way is to do it intuitively, and one way is to do it using vector mathematics. I'll show you both. Okay? You'll see we end up with the same picture no matter what. If I was doing this using vector mathematics, what am I trying to find? Engine velocity. How would I get the VE by itself in this equation? So the engine velocity, did you say subtract? No, did you say subtract? Say yes.
Yeah, I did.
So you're saying it's that, except how do I subtract vectors? I don't. What do I... The engine velocity is going to be the ground velocity, which is due west at 250. Give myself more room. Plus the opposite of the wind. What was the wind originally, directionally, Will? So what's the opposite? What's negative north? This will give me the direction the plane has to point if it wants to go in a quote-unquote straight line. All lines are straight, Mr. Dueck, in a nice compass bearing. It's going to look like this. Oh, I forgot to put a number on there. 45. 250. And now I'll do the Pythagoras and the trig. Now, that's one way to do it. The other way to do it is to do it the way we did when we handled the river question, where we said, look, if the airplane is getting pushed that way, what direction is it going to have to point? Down at an angle. You could actually say, I don't know what the engine velocity is, but I know as a picture it's going to look like that. Plus the north wind equals 250. Now look how that works. Nina, how would I add these two vectors together? Draw them. And I know exactly what this triangle is going to look like. Here is my mystery engine velocity, because I know that the resultant is pointing exactly west. Tell me when to stop drawing the wind. Okay? This is how we handle the river question, where we wanted to see if we wanted to go straight across the river, which way we had to point the motor. And this is really the same question. So there's two ways to get there. This is going to be 45. The engine is 250. Here's what I want you to notice. Do both of these lines for V engine, can I get them on one screen? Don't they look identical? And I'm going to get the same magnitude with Pythagoras, because they're both hypotenuses, so it's going to be 250 squared plus 45 squared equals that squared. And I'm going to get the same theta for both of them. I don't care which method you used. I probably would use this method because it's a little more plug and chug. Oh, let's get it by itself, let's subtract, and I know how to subtract. This one requires you to kind of see the entire triangle in your head and have that, I know what this has to look like moment. So no matter what, the magnitude is going to be 45 squared plus 250 squared square root. 254, is that what you got for a magnitude? And that was meters per second at opposite adjacent tan theta equals 45 over 250. $10.2 degrees. North of south, east of west, what of what? This looks like it's south of west. Does that make sense? Yeah, it's getting pushed north, so they have to point south. Or 79.8 degrees west of south, but the same magnitude. If you got that, 7 out of 7. If not, here's how I would give you part marks. I would give you 1 whole mark if I saw you'd bothered writing that. I would give you 1 mark if I saw a vector diagram, either that one or that one. I would give you 1 mark for that magnitude, that's 3. I would give you 1 mark for the theta, that's 4. I would give you 1 mark for the south, that's 5. I would give you 1 mark for that, that's 6. And I would give you 1 mark if I saw tangent somewhere, that's 7. So if you only made 1 mistake, and probably the most common mistake is in here, if you got one of those wrong, just subtract from 7. Oh, I got both of those wrong, but I got that and that right. 5 out of 7, even if you didn't necessarily write every other step. Yeah. You're going to have to bring it up and show me. And so now I'm going to pause, and I'm going to say, can you give yourself a lovely score on the top of your quiz? While the recording was stopped, I played catch with a few of you. The mathematics that we're going to spend a couple of days doing is very difficult, but every one of you does it in your head intuitively from about the age of 6 or 7 when you learn how to track an object with your eyes and position your body and your hands in exactly the right location to catch it. All of you can do this intuitively. But now we're actually going to calculate it. You're going to see, holy smokes, my brain is doing some pretty impressive stuff subconsciously. A projectile is an object in free fall. Screen's frozen, Mr. Dueck. Thank you. Twice today. A projectile is an object in free fall. We've already studied last year one-dimensional projectiles. I showed you a video of me jumping out of an airplane. I mentioned I jumped out of an airplane. And we found that when you were in free fall, gravity was pulling you down, and you might even still have memorized what that acceleration was because we flogged it to death. What was the acceleration on Earth, near the Earth, due to gravity? 9.8, negative if you wanted to say down, but you're going to see this year sometimes we're going to let down be positive because it makes the math much easier. But yeah, 9.8. Now that we've learned vectors, we can study two-dimensional projectiles. We have a thought question, and once again we get to vote. How high you hold your hand up is how sure you are of the answer. I'm positive. I'm pretty sure. I'm only voting because Mr. Dueck will make fun of me if I don't vote. Mr. Dueck will make fun of you if you don't vote. Here's the question. A mass is held at shoulder level and fired horizontally. Look up. Here's my Nerf dart gun. Let's imagine it was way more powerful. And I held it exactly horizontal and level on shoulder level, and I pulled the trigger. What path would the dart trace out? Path A? That's this one here. Path B? Path C? It would go straight for a while and then come down. Or path D? This is the question. You're going to vote. Who says path A, Mr. Dueck? If you pulled the trigger, path A, path A, path A. Got one. Who says path B, Mr. Dueck? Path B. 1, 2. Who says path C, Mr. Dueck? Path C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Who says path D? What did you vote? Yeah. You voted B? Did you? What did you vote? You thought that so you'd like to do that? For which one? For B? Thank you. So I'm sensing we're not keen on A and we're not keen on D. Those of you that picked C have been lied to by movies. C is wrong. As soon as the projectile leaves the gun, as soon as you start throwing the projectile, as soon as the Nerf dart left the Nerf gun, gravity starts to pull it down. It doesn't go in a straight line right away. Now, movies have lied to you because they've taught you that bullets travel in a straight line. They do not. They do not. You have all seen the sniper scene where they show through the sniper scope, and the sniper, to hit the target, lines the X up on the target. If that's all it took, any idiot could be a sniper. I could do it in my sleep. Oh, all I gotta do is line up the X, piece of cake. That's garbage. That's not what happens. In real life, by the time the bullet gets to the target, it may have dropped this much, or it may have dropped a full meter. In real life, what the snipers are really doing, they're never lining the crosshairs up on the target. They're having to compensate for wind, but even if there's no wind, they have to compensate for the fact that as soon as the projectile leaves the gun, gravity is pulling it down. It's already starting to arc downwards, and so they're aiming well above the target. And that's where the practice and the skill comes in. So next time you see, and I guarantee in the next couple of years, you'll see that scene. It's such a cliche in the movies. They show through the scope, and if you see the X lining up the target, stand up in the theater and say, that's wrong! Tell everybody in the audience, that's garbage! Otherwise, any idiot, Dylan, I could be a sniper then in 10 minutes. Oh, I can line up an X pretty easy. Piece of cake. Pull a trigger, bada bing. If you're looking for an explanation, gravity acts instantly. There's no magic hovering for a while, and then the bullet starts to free fall. So those of you that picked B, well done. Another question. Once again, we're going to vote. Suppose we have two identical objects. Let's pretend we're my Nerf dart gun and just a Nerf dart. But you know what? Let's make them nice and heavy so we can remove air resistance, okay? So instead of a Nerf dart, let's pretend this was firing actual lead darts that are going to fall right away. Supposing I pulled the trigger and launched a lead dart horizontally, and at exactly the same time, I dropped an identical lead dart from the same height. So read along with me. It says this. Two identical objects are held at the same height above the ground. Object 1 is released and falls in free fall. At exactly the same time, object 2 is projected to the right and also falls to the ground. Which one hits the ground first? Option A, object 1 because it's traveling less of a distance. Option B, object 2 because it's moving faster, it's going to get to the ground faster. Or option C, they both hit at the same time. Ready? We're going to vote. Don't blurt out unanswered. Who says A? A. Who says B? Oh, you're A? A? Good. Who says B? Who says C? Put your pencils down, look up. That. Both travel the same vertical distance. Yes? What's a better way to write vertical distance? What letter would I use for distance? People, what letter would I use for distance? Loud and proud, huh? What letter would I use for vertical? Okay, so I conned you by typing. Let's write this cleverly. You don't cross it out. Let's just write this cleverly and shortly. You can leave that line there, but I would say this. dy from object 1 equals dy from object 2. That's a much shorter way to write. They both travel the same vertical distance. What's the initial vertical velocity of object 1? What's VI? What's the initial vertical velocity of object 2? I don't care about the horizontal. Vertically, what's its initial vertical velocity? Because when it starts off, it hasn't, right when it leaves, it hasn't started falling yet. What's the vertical acceleration of object 1? Negative 9.8. What's the vertical acceleration of object 2? Negative 9.8. If I have the same D and the same VI and the same A, don't I have to get the same T because of D equals VIT plus a half AT squared? Oh, you know what? Let's just for giggles get the T by itself. Over here, let's write D equals VIT plus a half AT squared, but VI is 0. How would you get that T by itself? Drew, how would I get this T by itself? What would I do with the 2? What would I do with the A? What's the A doing to the T? Adding, subtracting, multiplying. So how do I move it over? Divide. So you times the 2. Divide the A. That'll give me a T squared. I don't want a T squared. So are you telling me that it's going to be times the D by 2 divided by A square root? And since I have the same values for both of them, won't they both hit the ground at the same time? I'm going to call this T1, T2, and then I'll say, therefore, T1 equals T2. Now, you don't have to do an explanation like this. Victor, you can just make up numbers. Oh, let the height be 10 meters. A is negative 9.8, and I can show they hit the ground at the same time. Oh, let's circle the correct answer. What this shows us is that the horizontal and the vertical motions are independent. They don't affect each other. What happens horizontally has no effect on what happens vertically. In this demonstration, both masses have the same vertical motion, so they have to hit the ground at the same time. Here's our key idea. What was the vertical acceleration? You all know this. What's the vertical acceleration? You all know this. Can I get more than 2 people participating? What's the vertical acceleration? All of you know this. Here's the key idea. What's the horizontal acceleration of any projectile? Put your pencils down, look up. Nina, don't write this down. Don't write this down, any of you. The horizontal acceleration is 0. That's way too much writing. What would be a good letter to use for acceleration? Everybody! What would be a good letter to use for horizontal? Because I asked you to. Horizontal. I'm going to call these our physics no-brainers. Now, they're not no-brainers because you have to learn the physics. But from now on, if we're looking at a projectile, I know AY is negative 9.8. I know AX is 0. And I can write those 2 things down without even thinking about it as long as I'm on the Earth. But will we ever go to other planets? Not for a while. If you were to look at a strobe photo of a projectile launched over a cliff, you'd find the vertical distances are getting bigger because it's accelerating vertically, but you would find that the distance it travels horizontally is the same. Why is this? Because the horizontal acceleration is, everybody, 0. Not immediately intuitive, but that is what's going on. Now, because the horizontal acceleration is 0, that means the horizontal velocity is constant. The vertical velocity is changing, getting bigger, but negative. Is that okay? I'm not going to do that. Put your pencils down, look up. So what does that mean? Example 4 says this: consider this stop action photo of the projectile below. At each point along the path, indicate the velocity components. That's what A says. Let's do the horizontal velocity component first. Now, your first one looks like that. You don't need to trace it out, but I will just so you can see what I'm talking about. What's the horizontal acceleration of a projectile? It's the key idea. 0. So what can you tell me about the horizontal velocity? If there's no acceleration, the horizontal velocity will be, I'm looking forward to these letters, C. So the horizontal component would be that, Try and draw an identical horizontal component to that very first Vx. Eyeball it, but try and make them exactly the same length. What about the vertical component? As the ball goes up, what happens to its vertical speed? Bigger, smaller, or stays the same? When you throw something in the air, it goes faster and faster and faster and faster and faster until it vanishes? What happens to its vertical speed? Decreases. So if my initial vertical component was this big, here, a little smaller, stop clicking the pen, thank you. What about at the very top for a split second? What's the vertical speed? So I'm not going to draw anything. And then on the way down, it starts to increase, but in the negative direction. Not only that, if we were at the same height, if it was going up at 3 meters per second, when it reaches the same height on the way down, it'll be going down at negative 3 meters per second. It's a nice symmetrical pattern. And in fact, so when it hits the ground, I'll try and draw the Vy pointing down exactly the same length as this. It's going to look kind of like that. It says indicate the velocity components and fill in the key facts. Okay. At the top, Vy is 0. Now, we're being launched at an angle here, so let's break this into components. Let's call this Vx. Let's call this Vy initial. Mr. Dueck? What, Dylan? Why did you put an initial on the y, but you didn't bother putting an initial on the x? Jackie, what? Jacqueline, what? What's constant? Vx is constant, so the initial is final, is middle, is whenever. But the Vy is changing. When we get even with the launch, do you know what Vy is equal to? I gotta be fussy, not Vy initial. Negative Vy initial. Vy equals negative Vy initial. That can be handy sometimes because that's a piece of information, Lachlan, that you know that you might not realize that you knew. Just before impact, Vx is still going to be the same length. Vy would be substantially bigger. I can kind of draw it like that. Horizontal speed is blank because Ax is 0. What word can I put here? Jacqueline? What word? Constant? Vertical speed is changing. Why is it changing? Because Ay is, you all know this altogether, negative 9.8 meters per second squared. The biggest mistake, Eli, that you can make is to put a horizontal value into a vertical value or put a vertical value into a horizontal value. And I'll tell you the most common one. Kids want to put that 9.8 into an x equation because the fact that the acceleration is 0 creeps them out. They want there should be an acceleration, not horizontally. The horizontal is actually much easier because of that. Horizontal and vertical motions what that means is don't you dare put a horizontal into a vertical equation. Don't you dare, Samir, put a vertical into a horizontal equation. Don't put a vertical value into a horizontal. Thomas, don't put a horizontal value into a vertical. I'll snap. In a nice, loving teacher kind of way. We're going to go right to the tone. You're not going to have any homework for the weekend, I don't think. I like example 7. I like example 7. I like example 7. Example 7 is a nice one. I call this horizontally from a cliff. Can you see why I call this horizontally from a cliff? Okay. Now, I always try and give you an approach or a tool. If you are, so for example, how do I add vectors together? Draw them. If you're dealing with a projectile, your tool is going to be a T-table. Why do I call it a T-table? Because it looks like a letter. And I break it up into horizontal and vertical. Although here I wrote horizontal and vertical, I have a lovely abbreviation for horizontal. What letter could I use instead? X. And what letter could I use for vertical? So you're going to start to see, I draw a big T, I put an X, I put a Y. And I have two physics no-brainers that I can fill in. I can fill in AX and I can fill in AY. What's AX equal to as a number exactly? 0. What's AY equal to? Everything else I'm going to customize to the question. You may notice I actually haven't even read the question yet. Now I'm going to. It says find the flight time and the range of the projectile. Okay. I filled in my physics no-brainers. What else do I know? I see a 20. I think it's a velocity. Horizontal or vertical? Look at the picture. So I'm going to put Vx equals 20. I see a 50. That's a displacement. Is that one horizontal or vertical? So I'm going to put dy equals, and it's not 50. I've made a mistake. Can anybody see the very subtle mistake that I've made because it's a displacement? Negative 50. Am I ending up above or below from where I started? Negative 50. How many pieces of information do I know in the horizontal column right now? How many pieces of information do I know in the vertical column right now? Not enough. I need 3 to find the fourth. And you're going to find your strategy is going to be, I need to find that third thing. There is one more thing that I know. I know the initial vertical velocity. Right when I leave the cliff for a split second, what's Vy initial? Because I haven't started falling yet. How many horizontal things do I know? 2. How many vertical things do I know? 3. What's the first thing, Drew, they wanted me to find? Please look at your question. It's there. What's the first thing they wanted me to find? Time. By the way, and this is not meant to be a joke, but it is a dumb joke, you're going to spend most of your time finding time. Are you going to spend most of your time finding? Time. Which column do I know 3 things? I'm going to find time in this column. Now, I'm going to get a little organized. I'm going to put the letter A above flight time. I'm going to put the letter B above range, and I'll do A right here. I have my data listed here, so I'm not going to relist it. Making sure I only use vertical now. I'm looking for an equation that has a VI, an A, a D, and a T in it. There is one. Hey, some people are going to the formula sheets. Excellent. Which one, Drew? Here's a hint. I don't know VF. Yes and no. Okay. VIT plus a half AT squared. But what's VI vertically? So really I have this. D equals AT squared over 2. Drew, how would I get the T by itself? What would I do with that 2? What would I do with the A? What would I do with the squared? Are we having a little deja vu movement? Did I plan that? Oh, yes, I did. So you're telling me time is going to be 2 times D over A square root, which is going to be 2 times negative 50 over negative 9.8 square root. But yeah, you all have your calculators out and you're practicing and trying along with me, yes? Because that would be a good way to get better at this, yes? It's going to be 3 point something, that I can tell you. 3.19438. Okay. I'm going to use time to find other stuff, so I'm going to write down some extra sig figs first. I'm probably going to go 3.19438. And then since they did ask me to find time, I'm going to report the answer to 3 sig figs with units. I'll put a box around it. That's the answer. I would say the time is 3.19 seconds, but if you need me to use it to find something else, I'm going to use 3.19438 or my answer button if I can. Michael, what's B asking me to find? Look at the picture. See the range in the picture? Horizontal or vertical? They want me to find, look up, dx. That's the range. It's not trig. Someone said triangle. Actually, no, it's even easier. Wait, Mr. Dueck. How many things do I know in the horizontal column right now? I thought you said I know I need 3 to find the fourth, and I don't know 3. Or do I? What? Are you telling me that I can also put that time in that column as well? So you're telling me that I could have said t equals, I'll write 3.19, but I'll use 3.19438, that there? Michael, I'm looking for an equation that has a VI, an A, a T, and a D in it. There is one. It's the same equation that Drew read to us. By the way, you'll notice I'm trying to remind myself by putting X's on every vector, make sure I use that. And Michael didn't even bother reading that out because he said, I know the acceleration is 0. Most common mistake, kids want to put the 9.8 in there. So it's going to be 20 times, I'm going to write 3.19, but I'm going to use my answer button. How far away from the base of the cliff did this object land? 63.9 meters. That is horizontally from a cliff. On Monday, no, sorry, Thanksgiving. On Wednesday, we're going to look at ground at an angle. A little tougher. Did I say angle? This is going to be a job for components. Then we'll look at cliff at an angle. If you want to get a head start on the homework, it's up to you. I am going to assign all of number 1. If you feel from one example that you can handle it, you can get a head start there. But we'll pick up with this on Monday.